afternoon, folks. E7018. It's finger licking good. This is one of the most common electrodes you're going to run into in school, probably on the job too. A lot of structural pipe applications for this. Low hydrogen rod. And if you watch any videos or you're in school, you'll hear that this rod is not classified as a deep penetrating rod. It's more like a light to medium penetrating rod. Certainly not to say that it's weak. It makes very strong ductile welds, which is why it's so common in the construction and pipe fitting industry. But what I want to do today, I want to experiment a bit with what you can run over with this and have it burn out. So I got a couple pieces of 3/16 steel that I'm gonna try and induce some porosity and maybe some slag inclusions on, and then weld over them with 7018. And then I guess the best way that I can figure to test this out is to just take a grinder and start shaving down layers and see what I can see. See if I uncover any porosity or slag that was left there from the previous welds. And the reason I was kind of thinking about this was because a couple months ago I took my QC7 cert test, 6G pipe, 6-inch Schedule 80, which is an x-ray test. And when I was taking the test, I really took a lot of care to clean it out very well. I had like these little dentist picks, and I would clean the toes and go along with a flashlight and brush it all out. And I mean, part of the reason I couldn't quench it, I had to let it cool because it was, a cert test. You couldn't move it out of position, and I had a bit of extra time, make myself wait to keep it a little cool. But just kind of wondering how much all that extra cleaning had to do with it, because I did pass the test, and by all accounts the x-ray looked very clean. Not me trying to brag, although I will say I certainly put in the work to deserve that certification. But just wondering how much of it was really necessary, and if I really had to go that length to get a weld that was that clean. And so I want to mess around with it a bit today, see if we can burn out any of that porosity, burn out any of that slag, and we'll go from there. So this is what I got, just a piece of 3/16 steel, got some 7018 beads here, and I was able to get a bit of porosity in there. I'm leaving slag in these craters. Got a couple 6013s here. I tried to induce one of those like slag pockets you see sometimes, tried to use a pretty steep push angle, but of course didn't make a slag pocket when I actually wanted it. And then I just got a couple 6011s here with some spatter and slag on it. And what I'm going to do is I'm not going to clean these anymore than they are now. I just knocked some of the big slag chunks off. And I'm just going to start here and then weld over these with a new 7018. And I'll cool it in between each pass just to keep it fair. I don't want residual heat from the plate to maybe help one of these burn a little better than they would normally. So I'm going to cool it in between each pass, and then when we're done, I'm just going to kind of grind them down and see which one of these discontinuities are still there. If it burns it out, we'll just kind of see how it goes. So this is what I ended up with. Welded from here. I just welded all the way over the previous beads that had the slag and the porosity and the spatter and stuff like that. And they don't look that bad, actually. There's been times in school where I've just been running practice pipe or something, and a lot of times on a 5G or 6G on the bottom there, you get a lump of porosity. And sometimes if I was just practicing, I'd just not really worry about grinding it out and just run over it. And a lot of times that porosity will pop up through where you're starting. And not to mention, a lot of times, even on these, you get porosity on a start with 7018 just because it's cold and you kind of long arc it a little bit. And especially if it's a rod that it's like a half burnt rod and you file it down to start it again, a lot of times if the flux isn't quite right, it'll give you a little porosity, but that shouldn't matter for these results. But I have noticed that porosity will pop up a lot of times if you just try and run over it. So I'm a little surprised actually that didn't really happen on these. But again, on a test, I wouldn't chance it. I would grind the porosity out if you could see it. You're allowed a little bit, but there's probably some that you don't see. So if you see any, then you should. If you see some and you can get to it, then you should take the opportunity to grind it out. But we're going to grind those next and see if we could detect anything. And another thing I decided to do, I just ran a 7018 along this little piece of 1/4 inch or 3/16, whatever it is. And I'm going to try and do cut and etch on it. I don't have any etching solution, but I've got a couple ideas that I think can bring the weld nugget out. So I just thought of that along the way just to see what kind of penetration, just a normal bead on plate you can get with 1/8 inch 7018. So we'll head down to the basement and start grinding these up. I'm doing it in the basement because it's kind of nice out and the neighbors are out, and don't want to bug them too much. Although none of them ever seem to return that courtesy to me. But anyway, we'll see what's inside these welds. So I got these ground down, not all the way, but just until I started seeing those discontinuities crop up. The down here is a 6011, where there weren't really any discontinuities present in those 6011 welds. I just ran a little bead, just wanted to see what it would do over those ripples and stuff. And looks pretty clean in there. I could probably grind down a little more, and maybe some slag inclusions would pop up, but I don't think so, because in school a lot of the instructors said that it's not really a problem. Like if you run a root pass with 6010 or 6011, it's not really a big deal to run over that with the 7018 if you just kind of knock down the high spots and wire brush it quick, because that's very light slag coating that the 7018 will burn that out. So that kind of speaks to that a little bit there. These 6013s, those could have been in the weld itself. I didn't really notice that on first inspection, but the 7018 certainly didn't help to burn any of that out. And all 4 of these are 7018 beads, where I somewhat induced the porosity on that original bead and ran over it. And although it didn't crop up to the surface of the second weld, you could see it's still in there, and it certainly does not burn that porosity out. So that just goes to show you that porosity is certainly a discontinuity that you want to address if you're taking a test, because on an x-ray it would see all that. It would see these clusters of porosity, and a couple of these, that one probably in particular, would perhaps be cause for failure. I forget exactly what the criteria is. I think it's 1/8 combined porosity in 1 square inch, which is a big reason for trying to stagger your restarts, whether on the bottom of a pipe or the top with your cover passes and stuff. You stagger your restarts even just an inch apart, because you're almost always going to get a little bit of porosity on 7018 starts. So you want to play by the specifications and space that porosity out, because then it won't count. You can have a little porosity all over the pipe as long as it doesn't add up to more than an 1/8 inch within 1 square inch of weld. And I believe that's the specification. You don't want any if you can avoid it, but having good baked rods, hot rods, and clean metal certainly goes a long way. But as you can see, that porosity really didn't burn out very well at all. And probably not an extensive test, just kind of an idea I had. I would like to experiment a bit more, maybe with different joint configurations, with a groove weld maybe, or a fillet weld, because I've heard some people say that if you got like a corner or something like that, a lot of that slag can roll in there and trap it, and you won't be able to burn it out with a subsequent pass. But that was just kind of a quick idea I had, and definitely looks like porosity is not something you're going to be able to burn out with a 7018. These are that one weld I just laid on that. I got them polished up with kind of a dull flat disc, and I want to see if I can get this nugget to show up, and let's see how far this actually penetrated in. I didn't do any prep to the material besides just clean the mill scale off and run a bead on there, about 122 amps it was. So see if we can get that nugget to show up. Well, I was able to draw the nugget out by polishing it as much as I could and then putting some heat on it just with a propane torch, but it didn't really stay. It kind of disappeared as the metal cooled down. So and I probably wouldn't even be able to capture it very well on this camera anyway, so I just took a bit of Sharpie and marked out the weld nugget as best as I could notice it while it was visible, and that's about the penetration that it got. So maybe about an 1/8 inch at the most, about as much penetration as there is reinforcement on the top, roughly. So this is only 3/16, so it's really not a very deep penetrating rod, but then again, that's really not its intended purpose either, so it can't be faulted for that. It's just the nature of this rod and how it runs, and it's very good for its intended applications. And as we saw over here, really not so great for burning through when you're trying to get down to other stuff. So porosity is certainly nothing to mess around with. If you were to see that on a test, could easily fail an x-ray. Grind it out. When in doubt, grind it out. If you have to follow one welding slogan, then that's probably the one to follow, because you're not going to be able to burn that out even by turning it up. All you can do is grind that out. And again, I was surprised that porosity didn't pop up as much as I've seen it in other circumstances. It didn't pop up through that second weld that I ran over it, but as you can see, it's still in there, and that other pass certainly didn't burn it out. And on this one that I did, it's really only getting about an 1/8 inch penetration in optimal circumstances. If the metal was thicker, you know, draw more heat away, it might be even less than that, but good clean metal and a fairly hot in-scope setting for an 1/8 inch 7018, about an 1/8 inch penetration. So not conclusive by any means whatsoever. Again, I would like to maybe experiment with some different joint configurations, a groove weld fillet, and maybe even try a 6011 or a 6010 or another rod, see if that is any better for burning it out. Of course, 6010, if you're going to run over something with the intention of burning it out, 6010 is probably the rod to do it. I can only run 6011 with my current welders though, but just kind of interesting, kind of wondered about it, but definitely that porosity is something you want to dig out. Look forward to messing around with this a bit more in the future, maybe figuring out how to etch these welds and get some arc shots a little better. So that's all for now. Thanks for watching. I'll take care.